Are you in the confusion where to start your DevOps journey? Then think in this way. Where exactly the DevOps process starts? Of course, it starts from planning, but the technical activity starts from the writing code. Let's assume that you are not dealing with the application code. Then next immediate step is maintaining the source code. But maintaining the source code as versions and also working with group of people became unavoidable in most of the projects. So we need some tools which helps us to maintain source code, versions, and working with group of people. That is where Git and GitHub comes into the picture. So learning Git and GitHub would be the right point to start your DevOps journey. But there are a lot of things to know in Git and GitHub which creates confusion if people would like to understand in the DevOps engineer perspective. If you are also in the same position, then this course is for you. Welcome to my new course, Git and GitHub for DevOps Engineers. This course talks about Git and GitHub in the DevOps engineer perspective, how it works in the DevOps process from creating a repository to releasing code onto production. I spent most of the time to perform hands-on labs rather than theory, unlike my other courses. In the last section of this course, I have discussed about a real-time project to explain how exactly we can start working with a DevOps project. Hope this gives enough confidence to start working with a real-time projects. With that, I believe I have given enough information regarding this course. What do you learn inside this course? Hopefully, I will see you in the course. Thank you. Hello folks. In this lecture, we are going to discuss about course content overview so that you will get a clear idea what you are going to learn in this course. First section is getting ready. If you have any query, there are multiple mediums you can reach out to me. I have listed out all those over here. Next, what is version control system? How to set up Git on Windows and Linux systems and working with Git Bash. This is about first module. In second module, working with Git, here we are going to see how to create a repository and working with different stages of Git, comparing changes in the local repository. Next module is working with GitHub. Here we are going to see why do we need GitHub and how to create a GitHub account and creating a repository from GitHub account, cloning and pushing changes onto remote repository. Next, working with other developer. Here we are going to see how to work with other developers code. If we are unable to push changes onto remote repository, how can we resolve it? Enabling SSH-based authentication between Git and GitHub. How a developer write code and push it onto remote repository. This we see in this module. Next module is Git commits. What is Git commits? How does it work? Knowing about specific commit changes. Committing changes on GitHub GUI. These we talk in this module. Next, Git branches. Why do we need branches? Branching strategies and how branches works in the DevOps workflow. Committing changes on branches. Resolving merge conflicts. These we talk in the Git branches module. Next module is working with team. Here we talk about Git forks. What is pull request and how does it work? Working with private repositories. Protected branches and contributors. This we talk in working with team. Next, reverting changes. If we have done any changes to our working directory, how can we revert? Similar way, how can we revert from staging area and local repository and git ignore file? At last, we are working with a project. Here we talks about project overview, how to set up repositories for a new project, allowing developers to check in code, enabling DevOps workflow on dev branch, merging changes from dev branch to UAT branch, releasing code onto production. This project will give you a complete overview of how Git works in the real-time projects. As a nutshell, if we see course objectives, we are talking about Git and GitHub, DevOps engineer activities on Git and GitHub, how DevOps engineers works with developers, how Git and GitHub works in the DevOps, a real-time project. That's all for this lecture. See you in the next lecture. Hello guys. Before starting with our course, few housekeeping rules I would like to discuss. First thing, prerequisites. During this course, I'm executing few Linux commands. If you know Linux basics, well and good. If you don't have, don't worry, still you can follow along with me. If you are really curious about to learn Linux basics which are required for DevOps, maybe you can check out my other course, Linux for Cloud and DevOps Engineers. Next, AWS EC2 service. In this course, I'm going to use multiple EC2 instances during our project. For that, you should have AWS EC2 service knowledge. If you don't have, still don't worry, you can easily follow with me. Next, resources. I'm expecting that you should have an AWS account. If you don't have an AWS account, at the end of this course, I have added a separate lecture how to create an AWS account. You can watch that video to create an AWS account. Next, GitHub account. I'm going to create a GitHub account during this course, so you need not to create now itself. And the resources or documents which I use during this course are updated in this GitHub URL. Hello guys, a quick introduction about myself. My name is J.R. Shankar. I have 10 plus years of IT experience. I'm working as a DevOps consultant in one of the leading IT company. Apart from DevOps, I have also experience on AWS and Linux. I'm one of the content creator for our Galaxy Technologies YouTube channel. During this course, if you have any query, you can reach out to me through these mediums. Thanks for watching. See you in the next one. Hello friends, in this lecture we are going to see what is version control system and why do we need to use version control system. In our course we are going to use Git as our version control system. Let's go and see why version control system came into the picture. First, let's understand the problem. You want to write some code with group of people. Usually in real-time cases, group of people working on same project. Whenever group of people are working on same project, they need to collaborate with each other to write the code. I'm writing one module, another guy is writing another module. We want to combine this code or we want to understand what other person is developing and how I need to develop. This is the biggest problem and the exchange was happening manually, nothing but copying from one developer laptop to another developer laptop. And also it is very tricky to manage. Why? Because I have given my code to my peer today. Again tomorrow if I am doing some changes to my code, again I need to share with him. Like this, if we have more number of people working on same project, it is more complex. To avoid this problem, industry come up with a solution called version control system. Now let's see what is version control system. A system that keeps record of your changes. While you are writing your code, if you are doing any changes to your code, it is tracking or it records those changes. Let's take an example that I have written some code yesterday and today I have done some changes. Like this, every day I am modifying my code. But after 1 week, if I want to recollect what changes I have done today, it is quite difficult. Why? Because whatever changes I have done today causing for some issue, so I want to revert changes what I have done today. In this case, version control system works effectively. It remembers each and every change what we have done our code and when we have done. Next, allows for collaborative development. As I said, multiple people are working on same project. Code sharing is quite a difficult problem. But if we use version control system, it is very easy to share our code and work collaboratively. Next, allows you to know who made what changes and when. As I said, whenever we do any changes, it tracks those changes and remembers who has done those changes. Next, allows you to revert any changes. If we done some changes today, it is not working and I want to go back to yesterday's code, it is quite easy for me because it tracks what changes I have done today and allows me to revert to previous code. So these are the major advantages of using version control system. Now let's see what kind of version control systems are available. One is local, then centralized and distributed. First, let's understand what is local. Local version control system works on your local computer. It means that in my laptop, I can install this version control system and I can track my changes. Assume that I am updating my file multiple times, then each time the file will be recorded what changes you have done and when you have done those changes, and it always point to the latest update what you have done. If you want to go back to the previous version, you can go easily. But local version control system works if you are a single developer or you don't want to collaboratively work with your team. But this doesn't solve the problem if we want to write the code with a group of people. Next, let's see centralized version control system. In centralized version control system, you have a centralized repository or main server repository, and collaborators and developers communicates with the main server repository and write the code. And you don't have any local copy of your code or project in the centralized repository. In case if centralized repository is not accessible, developers or collaborators could not able to write the code. Why? Because this should be always accessible. So centralized repository solves the problem to work with group of people, but in case centralized repository is not accessible, it is a problem for the collaborators or developers. Next, let's see distributed version control system. Distributed version control system is the mostly or widely used version control system. Why? Because it has a main server repository as well as the local repository. Nothing but whatever code you are having, same code is available in the developer system. You can sync central repository with the local repository, and developers can continue write the code even though centralized repository is not accessible, because same code or project is available in the local system. They can write the code and commit in the local repository and they push it into the centralized repository. But in this case, pushing your changes directly to the centralized repository is not possible. You must push your changes into the local repository. From local repository, it will go to the centralized repository. In this case, even though centralized repository is not available or local repository is not available, there is no problem, because even other collaborators or developers also having the same code. You can push this code into the central repository. From there, again, everybody can able to pull it. So pull nothing but taking the code into your local repository, push nothing but pushing the code into the centralized repository. You are going to understand these terms little deeper in going forward sessions. Now let's see what and all version control systems are available in the market. Git is one of the version control system. Bitbucket, Subversion, Mercurial, Perforce, GitLab. Like this, we have multiple version control systems are there. Among these, we are using Git as our version control system. That's all for this lecture, and see you in the next video. Hello friends, welcome back. In previous lecture, we have seen what is version control system and the types of version control systems. As I said, we are going to use Git as our version control system. In this lecture, we are going to see how do we set up our Git environment. To demonstrate this Git course, I'm going to use two users, that is developer 1 who is working on Windows system. Developer 1 is going to work on my laptop. I'm going to install Git over here. Next, developer 2, we are going to create a Amazon Linux EC2 instance and will use it as a developer 2, so that you can understand how we can work with Git either on Windows or Linux system. So first, let's start with installing Git on developer 1 system, nothing but on my laptop. This is my laptop where I should install Git. Now let's go to browser and search for Git to install on Windows. This is my browser. Search for Git on Windows and you can see git-sem.com. This is the first link itself. Just click on this one. And here you can see downloading Git. We can install Git for Windows. This is for 32-bit and this is for 64-bit. Our system is 64-bit, so I'm going to install 64-bit. It takes a while to get it downloaded. Let's wait. Okay, we have downloaded Git software. Let's install this one on our Windows. Just click on that one so that it is a exe. Anyway, we can install it. To install, we need a admin privileges. I have admin privileges, so let's go. And I'm going with the default settings itself. Nothing to change. And install. Okay, installation is completed. We don't require view release notes. we will just launch the git bash. So if we launch it, it is going to open the git bash. Okay, this is my git bash, and if I increase the font size, you can see I'm a Veloxy user. This we called it as a git bash prompt. We can execute our Linux commands on Windows by using this one. Even I can do ls cd cat. So this is how we can install git on Windows system. In next video, we are going to see how to set up git on Linux system. Thanks for watching. See you in the next video. Hello guys, welcome back. In previous lecture, we have seen how to install Git on a Windows system. In this lecture, we are going to see how to install Git on a Linux system. But so far, we have a laptop which runs as a Windows system. We don't have any Linux system, right? This is where we can take advantage of cloud services. In my case, I'm using AWS Cloud to create a Linux system or Linux server. But in AWS, server we call it as a EC2 instance. So we are going to create a Linux EC2 instance. Now we should have an AWS account to create a Linux EC2 instance. I have already an AWS account. I'm going to use my AWS account. If you don't have an AWS account, don't worry. I have created separate lecture for how to create an AWS account and how can you launch a Linux EC2 instance on AWS Cloud. Those videos are available at the end of this Git course. Please go and watch there. If you are comfortable create a EC2 instance on AWS Cloud, you can continue with this lecture. But anyway, quickly I'm going to launch an EC2 instance even in this lecture as well, so you can follow along with me. Now let's jump into our AWS Management Console to create a Linux EC2 instance. This is my AWS Management Console landing page. Even once you have created your AWS account, you will get landed over here. And here you have regions. Regions nothing but just think like a cloud data centers. AWS provides data centers in different geographical regions. By default, you may landed on North Virginia, but usually I choose Mumbai region, which is near to me, and I can create EC2 instance under Mumbai region. Now, to create an EC2 instance, go to All Services. Under All Services, there is an option called EC2. Click over here to go to Compute Services. Now you can see here, this is my EC2 dashboard. I have already one running instance, and these are the resources, nothing but which are used by your EC2 instance. But I'm interested to create a Linux EC2 instance. For that, we have a option called Launch Instance. So Launch Instance, here you can see Launch Instance option. Just choose this option. Now you need to choose what kind of operating system do you want to install. As I said, we need to install Linux, right? But even in Linux also, we have multiple flavors. That is Amazon Linux. This is also Amazon Linux. Red Hat Enterprise Linux, SUSE Linux, Ubuntu. Okay, like this different flavors are there. But in our case, we are going with Amazon Linux. It is something like CentOS only. So let's choose this one. Next, T2 Micro, we can create one EC2 instance for free of cost on AWS Cloud. Next, go to Configure Instance Details. Nothing to change in this page. Then add storage. Even here also nothing to change. Then add tags. Here I'm going to name it as a developer. Why? Because we are using this as a developer 2 system and Windows as a developer 1 system. Next, configure security group. So security group nothing but firewalls which allows traffic to connect to your instance. In this case, I'm just going to create a new security group. I will name it as a Git SG. Okay, sorry, SG. And by default, we are opening port number 22. Port number 22 is the default port to connect to our Linux systems. Anyway, I have already explained all this stuff in our. If you are new to Linux, I would recommend you to go through with that course. Next, review and launch. Now let's launch it. While launching, we need to choose a key pair. Key pair nothing but a password to connect to our Linux system. So far, I have a key pair, but I'm going to create a new key pair for this server. that is git key. I'm going to name it, and while creating your key pair you should download it, otherwise you cannot log into your system. So I have downloaded my git key and little bit scroll, launch instance, sorry. Now our system is getting ready, view instances, and I will just open and show you where my key is located. And usually I keep my keys in one folder so that I don't miss my keys. Anyway, let's go and see. Okay, our system is up and running. You can see here it is in running state, nothing but we can connect to this system. And to avoid viewing all instances, I'm going to just use the tag like name, and name of our server is developer2 system, so that we can able to see only developer2 system. Let me scroll it up. So we need to use public IP to connect to our Linux system. And we also have a private IP, but we don't use private IP. Private IP is for internal communication. Anyway, I have explained this in our Linux course. There you will get all this information. Now, let's connect to this system. To connect to this system, we need a software called MobiXterm. So you can just go, okay, search for google.com, and if you search for MobiXterm, you will get a MobiXterm link, and it takes into website. And if you scroll down, you can see here get MobiXterm. From here you can download free version. For our case, I have already downloaded and installed MobiXterm on my laptop. So just open MobiXterm to connect to Linux system. This is MobiXterm which I have installed and opened on my system. Go to session and SSH. Give the IP address over here, and advanced settings. Here we should provide our key pair. Without this key pair we cannot able to log in. Then EC2 minus user. Okay, this is the default user to connect to a Linux system. Next, just OK to connect. That's it. I have logged into my Linux system, and let me increase the font size and go to as a become root. So sudo su minus is a command to log into root, because you have logged in as a user. As you know, if you want to install any softwares, you must be a administrative user. Usually in Windows we call it as a administrative user. On Linux we called him as a root user. Root user have the privileges to install any packages on our Linux system. Now if I search for git over here, you can see it is saying that command not found. Nothing but I don't know what you are talking. Now let's install git. To install git, yum install git and just enter. Now I would like to install this git. So git installation is completed. Now if I execute git, and you can see this time it is saying that syntax error, not saying that command not found. Okay, all right. This is how we can install git on Linux system, and even you can check out for git version. Git minus minus version is a command to check the git version. That's all for this lecture. See you in the next video. Hello friends, welcome back. In previous lectures, we have installed Git on Windows and Linux system. Now we should introduce ourselves to Git. Why? Because we have two developers, right? We don't know which developer is working from which system. Whenever I push my changes, we need to track it. Who has done that changes, right? That is the reason you should introduce yourself to Git. We should execute these commands to track our username and email ID. The command we should execute is git config -- global user.name followed by the username. In my case, I am going to give as a Shankar, and similar way user.email we should provide the email ID. And please remember about this email ID. We are going to discuss about this one in the later point of time. In my case, I am going to use arsr319@gmail.com. And this is one-time activity. Nothing but you don't do it frequently. Once you have installed Git, you should do this activity so that that system is registered on your name. And you can change it whenever you need. Once you have installed Git, it is always best practice that providing the username and email ID. You can display the username and email ID with the same command without the extra parameter. Okay. First, we'll display the username and email ID what is there in our Linux system. Then we'll do the same thing on our Windows. So this is my Linux system. Let me clear the screen and git config ---- global user.name. I'm just checking what is the username is there. So far there is no username. Similar way user.email. If I check, there is no email attached to this one. So let's set up username and email ID for this one. So username I'm just giving developer2 because as I said I'm going to use my Linux system as a developer2 system. And git config. Okay, I have already typed above developer2 at gmail.com. Just I'm giving developer2 at gmail.com. That's it. I have set up username and email ID on my Linux system. Now let's execute again. User.email ID you can see, and similar way user.name, and you can see developer2. Same thing I need to do on my Windows system. This is Windows system, right? Git bash. And if you have any confusion, what you can do, go to start button, search for git bash. Okay. So you can see here, this is git bash desktop app. Just right click on this one and open file location. So this is where the git bash is installed. I'm going to just create a shortcut on my desktop. So send to desktop. So now if I go to my desktop, you can see here git bash is there. You just double click to open this git bash. That's it. Let me increase the font size. And now if I execute the same commands over here, git config ---- global user.name, you can see I have already configured my name as a Shankar and also email. Okay, arsr319@gmail.com. I'm not going to change these details as a developer1 because just think that Shankar as a developer1 and developer2 is developer2 only. Okay, that's how we can introduce ourselves to Git. And also you can see this information with one more command, that is git config ---- list. It is going to display all the configurations which are done on the Git. So if I display this one, let me scroll it down. So let me scroll a little bit down. So here you can see here, this is from the starting of your command, and here you can see user.email and name as well. Apart from this, few other values are there. You can understand these at the later point of time. That's all for this lecture, and see you in the next lecture. Hello friends, welcome back. In this lecture, we are going to see how we can create a Git repository. Before that one, I would like to stress on few points. First point is all Git commands starts with Git. So whenever we execute any Git related commands, the command starts with Git. Even if you see in our previous lecture, while configuring our username and email ID, our command starts with Git. That is git config ---- global, right? Next, you should introduce yourself to Git. This is we have already done. If you don't introduce yourself to Git while pushing your changes, you may face some trouble, or else it won't track your real name. It may give some random name. If you have some random names in your commits, then we don't know who has done those changes. Next, Git works with repositories. So whenever we want to work with Git, we should create repositories. Without repositories, we cannot track our changes. Next, most of the Git commands should run inside a Git repository. So few commands may work without Git repositories, like git config commands, but most of the commands you should run inside Git repository. So these are the points you should remember while working with the Git. Now we are going to create a repository. There are two ways to create a repository, but we'll create a repository on our laptop first, then we'll see how it works in the later point of time. Now let's go and create a repository. Okay, this is my PC. I'm going inside to my C drive. Under C drive, I'm going to a folder called projects. Okay, so here I'm going to create a new directory. So let's go and create a new folder. Okay, this folder name I'm giving it as a demo repo. Okay, and go inside to demo repo. So this is my demo repository, and if I see the path, C drive, projects and demo repo is there. Now I would like to go here and initialize this as a repository. So to do that one, I can open my git bash and come over here, or else I can directly open my git bash over here. I will show you the two ways. So first thing is, if I open here and if I go to git bash here, once you installed git in your Windows, you can see this kind of option. So just click on this one. Now you can see your Velox user pwd, nothing but present working directory. You are under /projects demo repo. Okay, same location you are, right? Other way is, you have your git bash on your desktop, right? So this is our git bash. If I double click to open, and if I go to C drive, okay, now you can see you are under C drive. From C drive, then projects, right? Then git repo, sorry, demo repo. So this is how you can go. And if you observe, these all are Linux commands. If you install git bash, you can execute your Linux commands on Windows as well. So most of the Linux commands works on your Windows once you install git bash. But usually what we do is, we go to the our respective directory and we'll open git bash over here like this. Okay. So now I have opened my git bash over here. Now I would like to initialize this git repo directory as a repository. For that, we need to execute a command called git init dot nothing but current location, treat it as a git repository. Now what is my current location? pwd. I am under demo repo and git init dot. Once I give enter, you can see the changes over here. My repository has been initialized, and you can see there is one .git directory has been created. So whenever you see .git directory in your folder, it means that that is a Git repository. Now this demo repo became a Git repository. If I go outside and if I click on any other one, okay, like workspace, if I check, this is not Git repository. Why? Because there is no .git. So whenever you have .git, it means that it is a Git repository, right? So demo repo, let it be. So once you initialized your repository, you are ready to create files, and those files are getting tracked. So whatever files or directories you create inside demo repo, only those files and directories are tracked from now. Now to test this one, I am going to create a file. Now you can create a file from Windows or else from here. If you are creating from your git bash, you should familiar with the Linux commands. If you are not that much comfortable, you can create files from here. Okay. Now if I do ls over here, you can see it is not showing the .git directory. Why? Because in Linux, if you want to see hidden files, you should execute ls-a. A stands for it is going to display the hidden files. So whatever files are created with the dot in Linux, it treat it as a hidden files. And this dot and dot is a like working directory and parent directory. Now I'm going to create a file. I will create from our git bash as well as from our Windows. First, let me create with git bash. For that, I can use the cat greater than command and file1 I am giving. So file1, and this is line 1. This is line 2. Okay, is missing. Let it be and save it. That's it. Now you can see a file has been created over here, that is file1. And if I do ls, you can see file1, and this hidden file it won't display until we give -a command, but whenever we need, we can use that one. Now I'm going to create a file from here. I'm going to create a new text document. text document. I'm going to name it as a file2. Okay, so file2 I have created, and in file2 I haven't created any content. So if I do ls, you can see file1 and file2. File2 have the extension of txt because that is the text document. And if I open the file2, there is no content at all, right? So it is empty. If I open file1, you can see some content is there. I can keep some content over here. Open. This is file2 and save this file and close it off. And if I go here, cat file2.txt, you can see the content. This is file2. This is how you can add files to your repository either from Git bash or else from your Windows system, right? That's all for this lecture. In next lecture, we are going to see how we can track these changes. Thanks for watching. See you there. Hello friends, welcome back. In previous lecture, we have seen how to create a repository on our local system and how can we add files to that one. In this lecture, we are going to see what are the different stages are there in our Git repository. There is some certain procedure we should follow to add our content to Git repository. Just creating a file inside your repository doesn't add your file to repository. Whenever we create any files inside a repository, it starts tracking those files. That's it. If you want to add those files to a repository, we need to execute these commands. So first we'll understand the different stages. First thing is working area. Working area nothing but the folder which you have converted as a Git repository. We have executed git init dot right in our previous lecture. Let me show you that repository. So this is the repository which we have created in our previous lecture, and these are the files which we created. And let me open git bash over here. Let me increase the font size. And I will keep open both the screens so that it is easy for us to understand. And if I see pwd, I am under /projects demo repo, and these are the files I could see. So far we have converted this directory as a repository or else this folder as a repository, and we created these two files. So this we call it as a working area. Whenever you create any files under working area, it start tracking these files. Tracking the files doesn't mean that these files are added to repository. To add these files to repository, we should execute some certain commands. That is where I have mentioned. So if you see this one, we have files over here. Now we need to add those to index area. So index area or staging area both represents to the same. To add our files from working directory to staging area, we should execute command called git add. So git add is a command to add our files from working area to staging area. Once these files are available under staging area, we need to execute again git commit command to add these files to repository. So local repository or repository, we can add files to our local repository by using git commit command. Now let's jump back to our repository and we'll add our existing files to staging area, then repository. So to add our files to the staging area, we'll execute command called git add over there. So this is our Git repository, and we want to add these files to our staging area. For that, we should execute git add, right? And you should execute commands only on your Git bash. You cannot execute on your Windows or GUI. If you want to execute those on GUI, there is one more option, that is git GUI. Okay, so git GUI is a same thing. Instead of running your commands, you can do it from your GUI as well, like creating repository, cloning, all this stuff you can do. But most of the people, they don't use git GUI. We should use git bash only. So I'm not going to talk about git GUI in this training. We are just quitting this and we'll execute over here. We'll execute all our commands over here. Okay, so now git add and file name. So I can give git add file1. And if I want to add two files, git add file1 and file2.txt. It got as a txt extension. Why? Because we have created it from our GUI. But in Linux, whenever we create any file, it doesn't come up with any extension. Okay. So this is the one command to add our files. Other commands are git add dot. Dot nothing but in the current directory, whatever files are there, add all those files to staging area. That is another command. Another one is git add minus minus all. Okay, this is one more command which is going to add our all files to our repository. All are going to do the same activity. So we are going to use all these commands in going forward, but for now we'll do with the file name. Okay, file1 and file2 dot txt. Okay, I'm adding these two files. This is the command to add our files from working directory to staging area. So working directory nothing but whenever you initialize your repository, by default it becomes to the working directory. If you go outside of your repository, it is not working directory. It is a normal directory. That is the difference. But before executing this command, I will just execute one more command, that is git status. Git status is very useful command which tells you where is your files are located at this moment. Nothing but whether these files are at working area or else staging area, or is it committed to your repository. Now let's execute this git status command before executing git add command, and we'll see. It is saying on branch master. We are going to talk about this branch in later point of time, but until some period of time you can see only this message and no commits yet. What does it means? That there is no commits done in our repository yet. Means it is a fresh repository. I haven't added any files to our repository. We just created a repository. Under repository we created two files. Those are still under working directory. It is not yet added to our repository. And untracked files. So untracked files nothing but these files are at working area only. If it is come under to tracked, it means that staging area. Please remember, whenever the files are there in the staging area, it represents as tracked files. If it is in untracked means those are in working directory, and those are represented in the red color. Red color means it represents that those files are still at working area, not yet added to staging area. Okay, so to add these files you can use a command called git add file. Okay, this is one way to add. So same thing we are executing, right? Git add file1 and file2.txt. Same thing we are going to do to add these files to tracking, nothing but staging area. And nothing added to commit but untracked files present, which means that we haven't added any files to the staging area. If something is there in the staging area, then you can see over here nothing but those files are in the staging area. So you will understand in better way going forward. But so far what I'm going to do is, let me pull it a little bit down. I'm going to add git add file1. I'm not going to execute on both the files. We'll add only file1 to our staging area. Means file2.txt still it is at untracked or in working directory itself. Now we can see git status again. This time you can see, okay, no commits yet. We haven't done any commits, and changes to be committed, which means that these files are in the staging area. Whenever these are in staging area, it appears as a green color, and whenever those are in working directory, still it will show you in the red color. So untracked files nothing but this is still in the working directory. This is at staging area. And if you want to commit your changes to repository, you can do only on the files which are at staging area. Nothing but now file1 is in the staging area. I can commit this one, but not file2. If I want to add this one to my repository, then first I need to send it to the staging area. Then only I can commit it. Okay. Now let's do it again. Git add dot, or else I can do git add file2.txt. So it is going to add my file to staging area. Now if I check git status, both the files are in staging area, nothing there in the outside of staging area. Now I would like to commit these changes to my repository. To commit these changes to my repository, I should execute a command called git commit. Okay, git commit followed by your commit message. Commit message nothing but what changes you have done and what is the commits you are doing. Why? Because multiple developers are working and each developer might be doing his own changes, right? So this commit message represents what changes he has done in this commit. Okay, so before committing, I'm going to execute one more command, that is git log. Okay, so git log is a command which tells you that what and all commits you have done on your repository. If you see, there is no commits yet. Why? Because this is a fresh repository. Even though we added our files to our staging area, we haven't committed our changes to the repository. So git status will tell you that where exactly your files are there. Git log tells you that whether you have committed your changes or not. Okay, now I'm going to execute again git commit followed by the message. I'm going to tell that this is my first commit. Okay, I'm giving this is my first commit, but whenever you are giving commit, you need to use the -m flag. Okay, -m flag represents to the commit ID. Without -m flag, it doesn't take it up. Now let's execute, and you can see the output of this one. So master so and so, this is my first commit, and two files has been changed, nothing but two files has been added, and three instructions. Why? Because in one file two lines are there, another file one line is there, and plus nothing but we have added those files. If you remove some files on the existing file, then you can see minus over here, and created mode, nothing but current permissions on your file. So 644 is the default permission is available on these two files. This is how we can commit our changes to our repository. Now if I do git status, you should not able to see any files under working directory or staging area. Why? Because whatever files we have or whatever files we have created, those files are added to staging area and also committed to our repository. And if I check git log now, you can see one commit. Just to see this one, git commit, and it also giving a commit id. Yes, I missed to explain about it. This is the sha code or commit id we can call. So commit id will have the lengthy one, but first 6 characters would be fine to find out our commit because it is unique for each commit. And there is a head represents to the master. We are going to talk about this one in the later. And author, you just see this one, we have set up my username and email id, right? So this is going to display over here, nothing but who has done this commit and when he has done this commit and what is the commit id. This is the information. So like this we can commit our changes and we can track these changes. So now by looking at this commit, I can understand what commit he has done and what is his intention to made his commit, and also who has done this commit and when he has done this commit and what is commit id. All this information is displayed over here. Like this, whenever we add any commits, it is going to add in the git log that we can identify by using the git log command. Okay, so far we have done only one commit. Okay, so this is how we need to add those files. Now you may ask that is there any way to bypass this procedure? No, we must add our files first to staging area and then we can add it to the repository. Sometimes we can directly add to the repository if those files are already updated, but anyway we are going to see that one in the later point of time. But it must go with the staging and repository. Now I'm going to quickly show you the what and all commands we have executed. It is kind of recap. So we have executed a command called git add that adds files into the staging area. Then we have executed git commit that add changes to the local VCS. Nothing but in our laptop we have created a repository. To that repository we have added, right? Now git status shows current stage of repository, means in which location your existing files are available. That tells about the git status. Then git log shows commit history. We have seen how many commits we have done on our repository by using git log. So these are the commands we have used in this lecture. That's all for this lecture. See you in the next lecture. Hello folks, welcome back. In previous lecture we have seen git stages, right? In this lecture we are going to dig a little bit more inside to git stages. For that one we are going to use this demonstration. So far we have created two files and both the files are added to staging area by using git add command. Then we have pushed those changes to the our local repository. So now file 1 and file 2 is already at our local repository. Now we are going to create two more files, that is file 3 and file 4. But out of this, only file 3 I am going to add to our staging area. Okay, so which means that we have file 1 and file 2 in the local repository, file 3 in the staging area, and file 4 I'm not going to add even for staging area, so it will be in the working directory. Okay, then we'll do some modifications on the file 2, file 3 and file 4, and we'll see the git status command, which is recognized by the git status and on which location, nothing but whether it is identified in the working directory or staging area and local repository. Let's see how does it goes. This is my repository which I have initiated, that is demo repo. I'm going to take git bash over here, and let me increase font size. Let me pull it down and increase little more. And if I see pwd, yes, our current location, and the ls, we have file 1 and file 2. For better naming convention, instead of using file2.txt, I'm going to use as a file 2, but later time we will modify because each modification will be tracked under git. Now, as we discussed in our demonstration, we are going to create two more files, that is touch file 3 and file 4. Okay, these two files we are creating. Now if I check, we have four files, and git status, if I check now, you can see two files are there, that is file 3 and file 4. Why it is not showing file 1 and file 2? Why? Because these two files are already staged and updated in our local repository. After updating in our local repository, there is no modifications on these files. That is the reason it won't show under untracked, because I have already tracked and reported in my GitHub repository. Alright, so now to add these files to our staging area, we should execute git add file name. As I shown you, we are going to add only file 3 to our staging area, and file 4 I don't add to our staging area. Let it be in the working directory. Working directory, nothing but it will be in red color under untracked files. Now let's add git add file 3, and if I do git status, now you can see under changes to be committed, nothing but this is staging area. In staging area, we have a new file called file 3. I have added file 3 to our staging area. File 4 is still untracked, nothing but I haven't added this one from our working directory to staging area. Okay. Anyway, these two files are empty files, nothing but we haven't added any content to these files. Let me open file 3 and cat file 4. Okay, both are empty, and equivalent changes you can see over here also. That is the reason I keep it open. Now I'm going to add some content to file 3 and file 4. So vi file 3, I'm going to just name it as a this is file 3 and save this file. Similar way, file 4, this is file 4, and save this. That's it. We have updated both the files, but out of these two files, file 3 is only in the staging area. And one more thing, I'm going to update file 2 as well. So file 2 also empty. I think this is, not file 2, right? It is file 2.txt. Otherwise, it is going to create a new file with the file 2. So file 2.txt, I'm modifying. So this is file 2, and this is a text file. Okay, that's it. So we have modified three files. File 1 we haven't modified, file 2 we have modified, but file 2 is already in the our local repository. File 3 also modified, but file 3 is only available in our staging area. Let me show you in the image. So this is what we have done. So far we have file 1 and file 2 are there, both are available in the local repository, and file 3 is only in the staging area. It is not yet added to local repository. To add to local repository, we should use git commit, right? But on file 3 we haven't used it, and file 4 is in working directory only, nothing but it is not yet in the staging area. Now let's go back and check for git status. Now you can see here there are changes to be committed, nothing but this is staging area. So in staging area, file 3 is there. At the same time, file 3 is also available in the working directory. See here in the working directory, it has been modified. Nothing but you have added file 3 in the staging area. After that, again you have done some changes to your file 3. Similar way, file 2. File 2 we have added to our repository. It is not there in the staging area anymore. Okay, it is in our repository. After adding file 2 into repository, again we have modified. That is the reason it is showing in the working directory only. Nothing but these three commits we have to do in our staging area. Now, how can I add these changes to our staging area all together? For that, we can use git add dot. Okay, git add dot is a command where we can add all our files to staging area at a go. So let's execute, and if I check git status now, you can see all changes has been tracked now, but it is treating that new file, file 3 is new file, and file 4 also new file, file 2 we have modified it. Okay, so this is how we can push our changes to the staging area. Now I would like to commit these changes to our local repository. For that, again git commit -m, adding file 3 and file 4 as well. Okay, and close this and enter. That's it. We have pushed our changes to repository, and 3 files has been changed or updated, and 4 instructions, nothing but 4 lines. One deletion, nothing but in file 2 we have given enter, so it treated it as a deleted and updated one more line. That is how it treat. Okay, so this is how we can commit our changes to our local repository. Now if I check for commits, git log, right? Git log is a command to list out all the commits which we have done in our local repository, and this time it should be 2 commits. So this is the first commit and this is second commit. All right, so this is how we can commit our changes to local repository. That's all for this video. See you in the next video. Hello friends, welcome back. In this video we are going to see how can we compare our changes from working directory to staging area, at the same time staging area to local repo, or else working directory to local repo. So how can we do those comparisons? First, let's start with the comparison between the working directory to staging area. Nothing but we have 4 files in our working directory. We'll modify and we'll send couple of files into staging area. Then again we'll modify and see the comparisons. Anyway, I'm going to show you with an example how we can do that one. So this is my Git repository. So far we have 4 files over here. Let me clear the screen, and pwd and ls. So 4 files we have. Now I'm going to update couple of files. Nothing but file 1 and file 2 I'm going to update. Let it be file 3 and file 4, and we'll add these 2 files to our staging area. Okay. For that I'm just going to update vi file 1, or else I can go here and open in a notepad and I can update. That also I can do. Okay, so anyway vi file 1, and here, so this line is 1 is there. I'm just going to update the typo. This is line 1. Nothing but I have done some changes, and if I do git status now, earlier we were not having any updated files. Okay, now we have updated it, so it is identified that there is a file updated in the working directory, but it hasn't added to the staging area. Even I want to update file 2 as well. So what I will do, I will rename the file 2, because it is file2.txt instead of file2.txt. I'm going to make it as a just file 2. Now git status again if I do, but this time instead of it treat it as a updated one, it thinks that we have deleted file2.txt and we have created file 2. That is how it thinks. But anyway, our motto is we would like to add couple of files to our staging area. Now what I am going to do is I'm going to add these changes to staging area. I can add these changes to staging area at a go, that is git add -all. Okay, this is one command, or else git add dot, or else I need to give the each file name. So git add -all, because we have used git add dot in our previous lecture. Okay, so now let's execute, and if I do git status, now you can see here renamed, it identified after adding it to the staging area that this file file2.txt has been renamed as a file 2. Okay, so now these 2 files are there in the staging area, which means that we have pushed these changes. For time being we just leave the file 3 and file 4. So we have pushed our changes to the staging area. Again I am going to modify file 1 and file 2. Then we'll compare with the staging area files with our local repository. Okay, now again I am going to modify my files, that is vi file1, or else I'm going to add. Okay, let me try to update from my Windows system itself. So for that, let me open it. Come on, open with Notepad, and here line 1 is there. Okay, it is not taking it as a different lines. Now let me add it as a, this is line 3. Okay, that's it, and Control S, close this one. So we have updated file 1. Now I am going to update file 2 as well. Open with Notepad++. Okay, this is the text file we have added in previous lecture. Now I am going to remove this line and save this file because we have removed extension as well. Now let's go back, and if I check git status, now you can see, okay, two files are there. You can see file 1 and file 2 is there in the staging area as well as in the current working directory. Nothing but these changes are not yet tracked by our staging area. Okay, so initial changes are tracked, and whatever changes just now we have done, those changes are not yet updated in our staging area. Now how can I compare these two files? Nothing but these are staging area files, these are working directory area files, right? So for that we can use a command called git diff. Okay, git diff, what does it do? It is going to take the staging area files and the current working directory area files, and we'll see what changes we have done. Okay, that is what it is going to do. And to better understanding, you just think that this is version 2. Why? Because version 1 we have already updated in our local repository, and think that this is version 3. So now you can use git diff command, and we'll see what is the output we are going to see. You just see here what happened. It is comparing the file which is there in the working directory to the file which is there in the staging area. B stands for staging area. And you just see here, this is line 1. We have added one enter in our notepad, right? That treated it as a plus. And we have also added line 3. So we have added 2 lines. That is what it is trying to say. So extra 2 lines are added in the working area file. Similar way, if I compare with the file 2, one line has been deleted in the working area file. Working area file, nothing but red color files. Okay, so that is what happened. Nothing but in version 3, these additional changes we have done. Whenever there is addition of a line, it will appear as a green color. Whenever there is a deletion, it appears as a red color. Okay, so this is how we can compare working area directory files with staging area files. Now I would like to compare the files which are there in my local repository with the staging area files. Means same file 1 and file 2. File 2 is not there anyway. File 1 is already there in our local repository, right? But file2.txt is there in our local repository. To compare with the local directory repository with our staging area, then we need to use a command called git diff -- staged. Okay, so git diff -- staged. Now let's execute this one and we'll see what will happen. You can just see here, it is comparing only file 1. Yeah, even it is comparing with file 2 as well. Okay, it identified the file 2 as well. Anyway, you can see here file 1. In file 1, what we have done, it is comparing with the what we have committed in our local repository with the file which is there in the staging area, not in the working directory area. In working directory area, we have added one more line, right? This is line 3, but that is not tracked. Why? Because it is comparing with files which are there in the staging area with the files which are there in our local repository. These two it is comparing. So here in this file we were having this line 1 is there because there was a typo. This is line 1 was not there. So this line 1 is there, and also this is line 2. That 2 lines were there in the file 1. But here we have updated the typo. So updated one it is going to compare. Similar way, file2.txt is there. Here we have modified file2.txt to file 2. That is the reason it is showing those two differences. Now you can see here we have removed the this line 1 and we have updated that with the this is line 1. That is how it identifies. And last one space was extra there in the previous one that we have removed over here. That is how it identified. Okay, so now the comparisons are happened with the local repository with staging area. Okay, so this is how we can compare working directory area files with staging area and staging area files with local repository. to compare with working directory area files with staging area, then we can just use git diff. Whereas if we want to compare with the staging area files with local repository, git diff minus minus staged. That is the command we need to use. We have one more command, that is git diff minus minus staged head. Okay. So this also similar way, same whatever output we got with the git diff staged, same thing we are going to get, which means that find out the differentiation between the stage and the head nothing but with the repository. Now let me pull it little bit and try to execute this command again. You can see same output you could see. Now one last thing I want to do, that is I would like to compare with the working directory with the local repository. Nothing but whatever changes I have done over here and what are the commits I have done, I would like to compare these two. If you do remember, in file 3 over here we have 3 lines, here we have 2 lines, but one line is with typo. So this line 1, this is the entry is there in the file 1, and here file 2 as file2.txt, here it is file 2. So I don't think so file 2 it is going to compare, but let's see how does it work. So git diff just head. Okay, so which means that if I give git diff, it is going to compare with the working directory with staging, right? If I give git diff head, it is going to compare with the repository rather than staging area. But anyway, you are going to identify what is head in the later point of time. But for now, just think that head means it is like a local repository. Now let me execute this one and you can see. So in file 1, it is identified that this line has been removed in the working directory area file, and we have added this, and also we have added one extra line, one more extra line over here. Similar way, it is identified that there is a file 2, a new file has been created because it thinks that file2.txt and file2 is both are differ. So in working directory, one new file called file2 has been created. At the same time, it thinks that file2.txt has been deleted, so it is going to delete. This is how we can compare our changes with working directory to staging area to local repo, and local repo to working directory. Okay, just quickly run through the commands what we have discussed so far. So the first command which we executed is git diff. It is going to compare changes of working directory with the staging area. Next, git diff minus minus staged, it is going to compare staging area changes with local repository. Instead of this command, we can also use git diff minus minus staged space head. That also works or give the same output. Next, git diff head, it is going to compare working directory with the local repository. That is how git diff commands are going to work. That's all for this lecture, and see you in the next lecture. Hello friends, welcome back. In this lecture, we are going to talk about commits. We have already done couple of commits. We are going to do one more and we'll check it out. Difference between each commit. For that one, I'm just opening my git bash over here. Okay, let me increase font size, and I could see there is warning. Okay, on file 1 because we have edited this file 1 with the notepad. So that could be the issue. So what I'm going to do is let me remove the file 1 and git status. Let it be in the staging area. We'll commit these onto our local repository. So now git add dot, nothing but whatever changes I have done, all changes I'm adding it to my local repository. Git status and git commit -m updated files. Okay, so we are committing our changes, and we have done one more commit. Now if I check git log, we could see 3 commits. So far we have done 3 commits, and you can see head points to the latest commit which we have done. Now I would like to compare the changes between the latest commit with the previous commit. For that we can do git diff. Let me pull this side. So git diff, and I can give the entire commit ID or else first 6 digits of your commit ID. So this is first 6 digits, right? I can give the first 6 or 7 digits of my commit ID with the other commit so that we can compare this one with our previous commit. You can see here. So here it is comparing with 2 different commits, and this is the latest commit and this is the older commit. So in latest commit /a file1 and older commit /b file1. So if you see the /a file1, nothing but in the latest commit, you can see triple minus and dev null, which represents that in the latest commit, there is no file called file1. Why? Because we have removed it, right? Whatever changes we have there in our working directory, all has been committed. And you can just check this one, git status. All the commits are done at the local repository. That is the reason there is no file called file1 at this moment in our repository. But in the previous commit, nothing but in this commit, there was a file called file1, and these were the lines were there in that file. Next, we are comparing with file2. So file2 is there in the latest commit, but not in the older commit. Older commit file2.txt, right? So that is what it is representing. In the latest file, we have file2, nothing but a/file2, and previous one, there is no file called file2. That is the reason it is showing as a del null. And in the latest commit, these are the lines we have added. Similar way, if we check the file2.txt, file2.txt is there in the previous commit, not in the latest commit. So if you see here, dev null, nothing but in the latest commit, there is no file2.txt. We just have file2. In the older commit, we have file2.txt, and these are the entries in that file. That is how we can compare two different commits using git diff command. That is how we can compare two different commits. Now we can do same comparison with the initial commit, nothing but first commit. For that, let me clear the screen and git log. If I do, you can see three commits are there. Now I would like to compare this commit with this commit. For that, I am going to use git diff, and I am giving minimum 6 or 7 entries we should give. After that, it can be anything, and you can just see this what and all differences we could see. Of course, file1 is not there in the latest commit. In initial commit, it is there. Similar way, file2 is here in this commit, but not in the previous commit. That is why dev null. Next, file2.txt, now it is not there. In first commit, it was there. Similar way, file3 is here, nothing but in this commit we have file3, but in the previous commit we don't have file3. And in the latest commit, we have added this line, and let me give enter. And also file4 we have in the latest commit, but not in the previous commit. That is how we can compare. Okay, so this is how we can compare which files are added in which commit. But there are other ways we can compare in better way. We are going to see those in the later point of time. But if you observe, so far we are working on our local system, and we are not sharing our code with any other team member who want to work with us. We are just doing changes in our directory or repository and adding it to our local repository. Now let's just think that developer 2 also want to work on the same code. Means me and developer 2 both are working on the same project. If that is the case, how we can share our code with the other team members? That is what we are going to discuss in the next section. Thanks for watching, and see you in the next section. Hello guys, welcome back. In previous lecture, we have seen how to install Git on Windows and Linux system, also creating repositories and pushing our code onto the repository. I mean to say local repository. But if you do remember the activities what we have done so far, we are doing all the activities in our Windows system or Windows laptop. We haven't communicated with any other system. Even our repository also still exists in our local system. So far it is fine, but if you want to work with a team, it doesn't work like this. And most of the cases you don't work alone. That is where you need to share your code with other team members. Assume that you have another team member you would like to share your code. Directly sharing your code is not possible. Why? Because you need to copy entire repository each and every time, and also it is difficult to copy your repository whenever we need. Why? Because this system may be up or not. And if more people are start using this repository, the more difficulty you are facing. So to overcome this kind of problem, we need to use a separate system where we can keep our repository on that system, and we can push our changes over there, and other developers can pull that code from that location. That is where GitHub comes into the picture. So what is GitHub? GitHub is a code hosting platform where we can host our repositories, so other developers can able to use those repositories and do the changes to the same code. So the major advantage of using GitHub is we can work with team or we can work collaboratively. Without GitHub, we cannot able to achieve the distributed version control system. If you do remember, we were talking about distributed version control system in our initial class, right? Let me quickly go through with that once again. This is distributed version control system. So far, assume that I am working over here. Assume that this is my laptop and I have created repository and all the code is available over here. And sharing the code over here is a difficulty. That is where we are using GitHub as a main server repository, which can help us to distribute our code with other developers. That is how we can enable distributed version control system. Let's come back. Now, how can I send my code over here? So far my code is available in my laptop. I would like to send it to the GitHub so that other developer can able to pull my code. In this case, other developer nothing but developer 2, where we have created a Linux system on AWS cloud and installed Git, right? From that system, I want to do some activities on the same repository. So we should push our code onto the GitHub. But to push our code onto GitHub, we should have a GitHub account. So how to create a GitHub account, we are going to see in the next lecture. Thanks for watching and see you there. Hello guys, welcome back. In this lecture, we are going to see how to create a GitHub account. As I discussed in our previous lecture, to store our code or to share our code with the group of people or with team, we should have a GitHub account, right? Let's go and create it. I'm on my browser. Let's search for create GitHub account. Okay, you can see first link github.com and join. Let me click on this one. And this is taking us directly to a create your account page. Rather than coming over here, let's go to home page. And this is the home page of github.com. Okay. Here you can sign up by clicking on this one, or else by default it is a sign up page. We can provide our details over here. So I'm going to give some username, and this username should be unique. It should not be identical. I'm giving Velaxy demo account. Okay, just I'm giving some random name so that this account name should not be used by any others. And email ID I'm giving velaxytechnologies@gmail.com. Hopefully with this account I don't have any GitHub account, and I'm giving some password. Okay, I have given email ID and password. Now sign up for GitHub. So it came to the create your account page. Here we need to verify our account. To verify our account, we need to solve a puzzle. So let's verify. Done. And join a free plan. And this you can uncheck if you don't want to receive any notifications. And what kind of work do you do? I'm a software engineer student or product manager. In this case, I'm software engineer I'm choosing. Next, how much programming experience do you have? I can say a little. And what do you plan to use GitHub? I can say that learn Git and GitHub. I'm interested. So in case if you are interested on any languages, you can specify over here. But I'm leaving this as empty and complete setup. So now my account has been created, but to activate it, we need to validate our email ID. But I have already an account, so I don't want to create a new account again. But this is how we can create an account. Let me log into my existing account. For that one, I'm going back to my github.com. And it is by default logged into Velaxy demo account. I'm deleting this account because I don't want to create this account. Just quickly account and delete account. Okay, why? Because I don't need this account. Your username or email ID Velaxy. So we are deleting. Now I'm going to log in my default account, that is github.com, and sign in for my account. My account is ARSR319 and I'm logging into my account. Alright, I have logged into my GitHub account and this is the default landing page. I could see few repositories over here, but in your case you might not see these repositories if you create a new account. And you can find out more information about your account by clicking on your account settings. And I have logged in as a revd. Revd is my username, and you can see your profile, repositories, projects, all this information is there. So let me click on my profile, and this is the profile, and by default you will be in the overview page. And if you want to change your information, you can change it over here. And this will tell you that how frequently you are working on your repository. Green color means you are working actively on these areas. No color means it means that you are not working at all. Anyway, I have total 58 repositories on this account, and I can check out my repositories by clicking over here. So these all are the repositories which are available on this account. Anyway, we are going to see little more in the later point of time. In previous section, we have created a repository on our local system, right, by using git init. But here we need to create a repository over here by using new option. Anyway, we are going to see that one in the next video. Thanks for watching and see you there. Hello guys, welcome back. In previous lecture, we have seen how to create a GitHub account. In this lecture, we are going to create a repository on GitHub. If you do remember, in previous section, we have created a GitHub repository on Git, nothing but in our local system. But in this lecture, we are going to create a repository over here, GitHub, and we can pull that repository onto our local system and do activities. Anyway, as a starting point, we should create a GitHub repository. Let's go and create a repository. This is my GitHub account, and as I said, I have 58 repositories so far, and I'm going to create a new repository by choosing this option, or else I can choose this plus symbol to create a new repository. And moreover, to create a new repository, you must log into your account. Okay, so I have already logged in, so I can able to create a new repository. So this repository is going to create under revd account. I'm going to name it as a Galaxy Technologies Git repo. Okay, so just I'm going to give the relevant name so that it is easy for us to remember. This is Galaxy Technologies Git repo. And if you scroll down, you can provide a description if you wish. I'm not giving any description. And another one is you can see public and private repositories, and just see the description what they have given. Anyone on the internet can see this repository. You can choose who can commit, which means that if you upload your code in the public repository, anybody in the internet, which means that this repository is publicly available. If they browse this repository from your account, they can able to see the content what is there in our repository. Whereas private repository, you can choose who can see and commit this repository. Means it is only available and accessible for the people to whom you can give access. So when can we use public and when can we use private? If you have a proprietary content and you don't want to disclose your code with any other person, then we can go with the private, and also you can restrict the access to specific persons or specific account holders. Whereas public repository, if you want to share your code with community and you are fine to share your code, in those cases we can use the public repositories. And moreover, if nothing to hide in the code what you have written. In our case, we can choose public repository because we are not going to keep any proprietary data in this repository, and a later point of time we may choose private repositories. Next, initialize this repository with add readme file, add.git.ignore. Okay, this is new feature, and choose a license. Okay, these two are new features. Earlier, these two options were not there. Anyway, first thing is add readme file. Usually in the readme file, we are going to give detailed information about your repository, what exactly it is doing, and in which cases we can use this repository. Something like this, you have written the code, and to understand what that code is doing is difficult and how to use that code is difficult, right? Instead of that one, you can update readme file by providing instructions how others can use your repository if they want. That is where we can write readme file. And while writing readme file, we must write in the markdown language, which we are going to see in the later point of time. For now, I'm just choosing this option, that to add readme file, and we don't need git ignore. We are going to talk about git ignore later point of time, and create a repository. Okay, so now I can say I have created a repository. The repository name is Veloxy Technologies Git repo, and in this we have one file that is readme.md. MD stands for Markdown language, and by default it adds just your repository name in this file. Okay, so this is the content added in your readme file. So this is how we can create a repository, and there are a lot of options are available over here, but majorly we can concentrate over here master. You can see this is the branch we called. You can see branches and master. By default it creates a branch called master, and all your content goes into the master branch, and we are going to talk about branches in the later point of time again. And it is initialized by revd initial commit, nothing but I have done one commit. We have seen commits by using git log, right? Same thing you can see here. And commits you can check it out over here. This is the one commit and it has done 1 minute ago. And here you can see go to file, add file, code. Okay, there are different options over here, and we are majorly going to use this one. That is, we want to clone this repository. To clone this repository we just need to click over here, and we need to take up this URL. Again, this URL is clone with HTTPS, and we have one more option that is use SSH. We are going to talk about SSH later point of time, but for now we are going to use HTTPS. So here if we click, it will get copied into our clipboard and we can use wherever we want. This is about how we can clone our repository, and apart from that we have issues, pull requests, actions, projects, wiki, insights and settings. Mostly we are dealing with settings. Okay, like that there are various options we have, but we are going to deal with some of these whenever it is necessary. I'm going back to code again, and this is our default landing page. That's all for this video. In next lecture we are going to clone this repository into developer system and start working with that. That is what we are going to see. Thanks for watching and see you there. Hey guys, welcome back. In previous lecture we have seen how to create a repository, right? In this lecture we are going to clone that repository onto our local system. How to clone, we are going to see that one. Before that one, let's understand how the local and remote repository works. If you see here, couple of commands you might be familiar by this time, that is git add command and git commit command. These two commands we have done, and move and remove, just ignore it. So git add, where we want to add our files from working area to staging area. Then git commit, where we want to add our commands from staging area to local repository. Now just keep this repository for aside. We have created a demo repo, right? So this is the repository we have created, demo repo. So this repository we are not using for some time. Let it keep aside. Now, after doing that one, what we have done, we have created our account on remote repository and we created a repository over here. So that repository I would like to clone into my local system. We are concentrating on this command git clone. So we are going to clone this repository onto workspace or onto our local system. So this is how our systems looks like at this moment. So just think that this is developer one or my laptop, and this is a Linux system, and a few other developers also want to get the same repository. And we have initialized a repository over here. And if I do git clone repository name, that repository is going to come onto my local system. Same thing we can do from the other systems as well to get this code or to get this repository. Anyway, we are going to execute git clone command to pull the code from our repository. Now let's jump into our GitHub account to get the URL of repository to clone it onto my local system. This is our remote repository which we have created in our previous lecture. So to clone this repository onto our local system, we need to take this repository URL. For that, click on code. Then we are going to use HTTPS URL. So copy this one and go back to our working directory. Now this is anyway repo. Inside a repo, again I don't want to create a repository, so go back over here. So under projects I'm going to clone that remote repository. For that I'm going to open git bash over here. So nothing but under projects folder we have initialized git bash. I have increased font size. Okay. Now you can just see here, if I do git status over here, you can see not a git repository. What does it mean? That it is not a repository, right? It is just a folder. Only demo repo is the repository. In case if you want to know that whether a directory is a repository or not, it should have .git directory. Here we don't have .git directory, so it is not a repository. If you want to convert this entire project folder as a repository, then we can execute git init dot. Okay, that we can do. But I don't want to do that one. For now, we just want to clone the repository onto this folder. For that, we need to use a command called git clone and the repository URL. So I have copied the repository URL, and you can see this is https github.com/revd. This is my account followed by the repository name, and it comes with .git extension. If I do this one, it is going to clone the repository onto my local system. My local system nothing but developer1 system, and you can see the vt repo has been created over here. And if I click over here, you can see .git and repo, nothing but it is a repository. And again, if I go back here and pwd present working directory, I'm under projects, and I should go inside to Galaxy Technologies git repo and clear the screen. And if I do ls over here, you can see only readme file is there. And if I open readme file, hash vt git repo, nothing but Galaxy Technologies git repo. So this is the content we have cloned from our remote repository. Now I can do my development activities on this repository, and I can push it back. How we can add changes and pushing these changes to the remote repository, we are going to see in the next lecture. Thanks for watching, and see you there. Hello guys, welcome back. So far our environment looks like this. We have a Git repository on GitHub, as well as same repository is available in our local system. Now I'm going to update my local repository with new code. After that, this repository is differ from the repository which we have there in GitHub. Let's take the example that even other developer, nothing but a developer 2, who is using our Linux system, it is on AWS. This guy also want to work on the same code along with developer 1. Now he don't know what changes developer 1 has done. If he is trying to pull this repository and start developing it, there may be a problem. That is the reason we need to push our code into the GitHub repository all the time, so that latest updates can be available for the developer 2 as well. For that, we should run a command called git push origin master. Here master nothing but a branch. I have shown you that while creating our GitHub repository, one branch has been created, right? So same branch we are going to push. Anyway, we are going to talk about this one more detailed in the later point of time. So when we execute this command, our code which is there in our local system is going to get updated with the GitHub repository. Now developer 2 can able to pull this code and start developing it. Again, to pull the code, he has to run the git clone, right? Because he has to clone this repository on his local system. When he run the git clone, code get pulled into the other developer system. This is what we are going to try in this. Now everybody's code is updated. So this is how GitHub helps us to share the code among the developers who are working on the same project. Now let's try the same thing. At this moment, our repositories looks like this. We have same code over here. Now I'm going to update our code over here. Let's go and do that. So this is our GitHub repository, which is cloned from GitHub. Now let's open git bash over here. Increase the font size. And here git status, if I check, you can see there is no changes in our branch. Whatever is there in our remote repository, same I have pulled over here. ls, you can see only readme file. Now assume that this is a HTML project. I want to create multiple HTML files on this one. Let's take that I'm creating index.html file. So for that, index.html, I'm writing it as a h1. This is index.html file, and I'm closing HTML. Okay, if you don't know the HTML, don't worry. This is just a header. I'm going to write it and save this file. Now if I see again git status, you can see there is index.html file. That is contact.html. va contact.html. So here I'm going to give our contact details are, I'm closing it up. Then I'm providing h2. Okay, h1 nothing but header 1, h2 nothing but header 2. Depends upon the numbers, the font size varies. Okay, phone number 123456789. Just I'm giving some random number and save the file. And I forgot to assume that I forgot to add an email to contact details. Let it be and save this file. And if I check a git status, so two files are there. From here, we have already tried how we can add these files to staging area and from there to local repository. So before committing this, if I check git log, you can see only one commit nothing but whenever we created our repository in the GitHub, at the time this commit was done, that commit was initial commit. We have added readme file, right? And also you can just see here author Rowdy, and because we haven't set up our email ID over there. And if you see the date when we have done the commit, and by default it treated as a initial commit, right? Now we are going to commit our changes to this repository. For that, git add dot. Okay, git add dot nothing but add all new files or modified files which are there in my current repository. That is the meaning of this command. So I have added. Now if I check git status, you can see these files has been added to staging area. Now from here I want to push it into my local repository. So git commit -m added contact and index files. Okay, so this is how we can add our files. And if I check git status, so now you can see here it is saying that your branch is ahead of origin master by one commit. What does it mean? Our branch nothing but our local repository have one extra commit comparatively my remote repository. So if I check git log now, you can see how many commits are there. We have two commits, right? But whereas if I go to my GitHub and if I look for commits, you can see here commit, still only one commit is there. So it is comparing this commit with the local commits which we have done on our system. And our origin, you can just see here origin master nothing but our GitHub account. In our GitHub account we are having this commit, whereas in our local repository we have extra this commit. Now I would like to make this commit in my remote repository. That is where we should use git push origin master. Whenever we execute this command, whatever changes I have done in my local repository, same are get updated with my remote repository. Here origin nothing but our centralized repository. Our centralized repository nothing but github.com. So we are trying to push our changes to our origin and onto master branch. Master nothing but onto this branch we are pushing. Let's try to execute this command and you can just see what happens at this moment. Okay, I could able to push my changes onto my remote repository. And now if I check in my remote repository by refreshing it, you can see one more commit over here. You can see here added contact and index files, and that is by Revdi. And by the way, whenever we are pushing our changes, it should ask for credentials. But in my case, my credentials are already recorded in my local system. That is the reason it is not asking for credentials. But I'm going to show you how to set up the credentials when we are dealing with the Linux system. Okay, again, I'm going back to my code, and this time I could see my index.html and contact.html, and it is updated 9 minutes ago. This 9 minutes is in our local repository when we have committed in our local repository. Content is same as what we have added. So this is how we can push our changes onto remote repository. Now assume that a developer too also want to work with this one. So as of now, we have done changes and changes has been pushed into remote repository. Now I would like to pull these changes onto other system, that is our Linux system. On Linux system, I want to pull and I want to do my modifications. How can I do that one? We'll see in the next lecture. Hello guys, welcome back. In previous lecture, we have seen how can we modify the code and push it into the GitHub, right? In this lecture, assume that developer 2 also want to work on the same code. Let's take the example. So this is available in the GitHub. So now developer 1 went and identified that in contact.html file, there is no email ID. Now developer 2 want to update email ID in the contact list. For that, he has to pull this code. He cannot directly update over here, right? Of course we can do, but that is not right way to do that one. For this, he has to pull this code onto his system. He has to add his changes to the code and push it back so that it will be available to everyone. Anyway, we are going to take this code, I mean to say whatever code is available in the GitHub, that code we will take it as a deployable code. So all the changes must be updated with the GitHub account code. For that, I need to log into my developer2 system. From there, I can pull this code. As you know, we have created a Linux system on AWS Cloud for developer2 system. And I'm going to log into this system. To log into this system, I'm taking the public IP address of this system and go to mobile extern. This is mobile extern session SSH and IP address. Next, we need to load the key pair. We have given key pair as git key, right? This is the key pair and the default user for EC2 server, that is EC2 minus user. That's it. Let's connect to this system. And now I have logged into my system. Now I'm going to rename it as a developer2 system so that it is easy for us to recognize. I'm logging as a root. For that, we need to execute sudo su minus, which means that switch as a root. So to edit hostname, we need to edit /etc hostname file. Here, this is the name we have, but I don't want to this name. I want to developer. Okay, something like this I need. But after changing hostname, you need to reboot your system. Rather than doing that one, you can just do hostname developer2 system. Okay, this is for temporary, nothing but until reboot, it will show as a developer2 system. Okay, special character is not allowed, I think. Minus I am giving. Okay, it has been updated. And also in host file also I should update it because it doesn't take special character. Right? Now let me switch once again as a root so that we can see the latest name. Okay, that's how you can do. Or else we can do the source, nothing but exit. Okay, source doesn't work because we need to reboot. Anyway, I'm going to switch back as a root user again. So now you can see your hostname has been changed as a developer2. Now let me clear the screen and pwd. At this moment, I am under root directory and there is no files over here. Now, how can I clone this code? It is very simple. Git clone followed by our repository name, right? So you know how to get the URL of repository. That is, go to our repository and click over here, get the repository, and go back to our system and give the repository. That's it. Now I have cloned this repository into my local system and you can see vt git repo. And if I go inside to vt git repo and here you can see contact.html, index.html and readme.html. Okay, so this is how we can clone code into another developer system. Now my purpose is I would like to update contact.html because developer1 forgot to update or did some mistake in the contact.html. Maybe here we are adding few lines, but this is how the concept does work. We may not using code at this moment, but this is how concept does work. So I'm editing contact.html and will add h2 email contact at email.com. Okay, just I'm giving some random name. So h2, that's it. We have updated our code and let's save this file. Now if I see git status, you can see one file has been modified in our local system and that is also available in the working directory. We need to add this one to our staging area, and git commands are same even though you are running on Windows or Linux. So git add dot git status. Now it is in the staging area. Git commit -m added email to contact. Okay. So by looking at this commit ID, I can identify that what changes developer 2 has done. Now if I check for git status, now you can see our local repository is ahead by one additional commit, whereas remote repository doesn't. And if I check git log, okay, you can see here this is the origin nothing but our remote repository. Our remote repository have commits only two, but my local system have one more additional commit. Okay, so that is the reason it is saying that our local system is forwarded by one additional commit. Now I would like to push these changes to my remote repository. Before pushing it, you can see author we have done it as a developer too, and this is the email ID. Now let's try to push these changes to remote repository and we'll see what happens. Git push origin master. Okay, you can see here it is asking for username where it didn't ask for username when I am pushing it from my Windows system. Why? Because in my Windows system my credentials are already stored. That is the reason it is not asking for credentials, whereas in my Linux system my credentials are not yet updated. That is the reason it is asking for credentials. Again, you may get one more doubt that while cloning the repository it didn't ask for credentials, but while pushing our changes it is asking for credentials. Why does it happen? Why? Because our GitHub is a public repository. Whenever it is a public repository, everybody can able to clone that one. But it doesn't mean that everybody can able to update my code, right? If somebody want to modify my code, they have to get my permission. Otherwise, they cannot able to modify. If you want to use my code, yes, you can use and you can do whatever changes you want. In this case also, developer 2 want to modify the code, he has modified it, but while he is pushing his code onto my repository, he should have my authentication, nothing but my credentials he should have. But giving my credentials to developer 2 is not right way. But just think that for this moment, we need credentials to push our changes, so that I have given my credentials to developer 2. But going forward, we don't use these credentials. Okay. So to proceed further, I am giving my credentials over here, that is ravd, and password also I am giving. So I have given my credentials, and these changes has been pushed into remote repository. And if I go and check it out in the remote repository, let me refresh it, and you can see here this time one more commit has been done, and that has came as a RT2. It means that somebody has created GitHub account with this email ID. That is the name it has propagated. Okay, anyway, if I check for the commits, you can see here 3 commits are there, and this commit just now it has been done and added email to contact list. And if I go to my code, I could able to see the latest commit. Okay, you can see here email contact@email.com. So this is how we can update the existing repository code as a another developer. And so for 2 developers are working on this code. That's the reason you can see the contributors are 2. In this file, 2 contributors are updated their code. So this is how we can pull the code and do modifications and push the changes. So this process continue to repeat until we get the expected output in our development process. That's all for this lecture, and see you in the next lecture. Hello guys, welcome back. In this lecture, we are going to see what is the difference between git clone and git pull. So far, we are using git clone to clone the repository. In this lecture, we are going to see the git pull. So to demonstrate this one, I am taking the same repository. In this repository, we have 3 commits at this moment. And same 3 commits are available in the developer 2 system as well. I just executed git log command, and you can see 3 commits are there, and these commits are updated in our remote repository. And if I check for developer 1 system, this is our developer 1 system, but in the developer 1 system we have only 2 commits, because third commit was done by the developer 2 and he updated this one in the remote repository. Remote repository nothing but over here he has updated. Now I would like to get these updates to my developer 1 system. For that we need to execute a command called git pull. Okay, so git pull I need to execute. Now what is the difference between git pull and git clone? In case the repository is not exist in your system, then we need to use the git clone. If we take our previous lecture, in our previous lecture, initially we have executed git clone over here. Okay, and then we have done our changes and we pushed over here. And even as a developer too also, initially he has used git clone command. Why? Because the repository itself is not exist in the local system. In case if it is not exist in the local system, then we need to go with the git clone. Whereas repository is already available, but few changes you want to pull from the remote repository. If that is the case, we need to use the git pull command. So here in my developer1 system, I have already this repository, that is Veloxy Technologies Git repo, but this is not up to date. Up to date nothing, but some commits are missing in my local system. So I should execute git pull command. Let's execute git pull and we'll see what happens. And here you can see it is pulling the changes, and you can see what changes it has pulled. Contact.html, and this file has been changed, and one insertion and one deletion. Deletion nothing but maybe we have deleted the space, empty line. That is the reason it is saying as a one deletion. Let me open the contact.html now. I have pulled it. That is the reason I could see this email in the developer1 system. And if I check git log again, this time it is going to show us 3 commits rather than 2 commits. And here we have head master, origin head. This we are going to talk about more detail in the later point of time. So in our local system, current head is representing to the master nothing but for our branch. So we are going to talk about head and this mapping in later point of time, but these are the commits. And here you can see this third commit was done by the developer too. I could able to see that one, and also he has given a description that added email to contact. So this is the major difference between the git clone and git pull. I'm repeating once again, we are going to use git clone command if we want to clone the repository from the GitHub first time. Nothing but in your local system, the repository is not there and you are cloning it. Git pull we are going to use in case repository is already there, but you want to check out whether your local repository and remote repository are at the same page or not. Nothing but whatever commits we have on the remote repository, same commits are there in the local repository or not. For that purpose, we are going to do the git pull. Now let's think in another way. Assume that developer 2 is not pulled latest code from GitHub, but he has done his own changes and he is trying to push it. What happens? That we are going to see in the next lecture. Okay, that's all for this lecture, and see you in the next lecture. Hello folks, in this lecture we are going to talk about a common issue which is faced by the developers and how do they resolve it to avoid the problem. Let's take an example that there is a repository in our GitHub account. Now developer 1 and developer 2 want to work on the same code. So to get that code, we need to pull it into our local system, right? For that, we can execute a command called git clone so that the code will come into the local system. Now assume that developer 1 has pulled the code. Similar way, even developer 2 also cloning the same repository. At this point of time, everybody have the same piece of code. Now developer 1 and developer 2 start working on this code. Let's assume that developer 1 has updated his code. Now there is some change or variation with the remote repository code. Similar way, even developer 2 also updated his code. Now both the guys have done their own changes to the same repository. Now we need to push this code onto remote repository, right? Now let's say that developer 1 is trying to check in his code onto remote repository. At this point of time, developer 1 can able to check in his code without any issue. Why? Because whatever commit ID on the remote repository and whatever commit ID he was having on local repository, both are same. Now on top of that one, he has done his own commits. So while pushing also, there won't be any problem. Developer 1 can able to update his code with the remote repository. Whereas if developer 2 is trying to update his code onto remote repository, it doesn't take it. Why? Because whenever you have pulled this code from the remote repository, the code what were there in the remote repository and what is there at this point of time, both are different. To avoid this problem, we need to pull the code by using git pull command, pushing our changes or checking in our changes. That is the best practice. Apart from this, we can still use git branches, which we are going to talk about those in the later part of this course. Let's see this demonstration with practical. So to demonstrate this example, I'm taking a repository called test hello. So far we have 12 commits over here. I'm going to clone this repository onto developer1 system as well as developer2 system. Let's go to developer1 system first. Developer1 system means my local system. I'm under projects directory. Under this, I have one more directory called Java projects. This time I'm going to clone my repository over here. So let's open git bash over here. Okay, so if I do pwd, I'm under Java projects. We have few existing projects over there. Anyway, I'm going to clone my repository, git clone. Let's take the repository. This is the repository and I'm cloning it over here. Alright, developer1 has been cloned this repository successfully. And if I do ls, we have a test hello. I'm inside to test hello. Similar way, I'm going to clone this repository onto developer2 system as well. This is developer2 system. I'm under root directory. I have already few existing repositories. Here I'm going to clone the repository. So even on Linux system or developer2 system also, I should use the same command. So we are cloning the repository. Now let me go to test hello and clear the screen. Now both the developers are start working on this repository. Let's assume that now both have the version 1 code, which means that git log if I do, you can just see here your current commit is at E97E. Even here also git log, your current commit is at E97E. Now while pushing my code, even in the remote repository also same commit should be there. If some other commit, you cannot able to push your code. Okay, so let me update a few content in this file. Let me go to src here. Okay, main java. Okay, I'm updating this file app.java. Some updates we need to do. Let's update this file. Something is there, so I'm just updating it as a welcome to DevOps training is there. This I'm going to change it as a welcome to training. Okay, so I'm just save this file, and if I do git status git add dot, I'm adding this onto local staging area git commit -m updated app.java file. Okay, so I have updated and this has been updated in the local repo. If I do git log, this has been updated in the local repo. Now if I want to push or if I want to check in this commit onto remote repository, I can do without any issues. Why? Because even my remote repository is still at this version. Okay, so if I go to commits, you can see here at this moment your remote repository also at E97E, that is the commit ID. Even in our developer1 system also in the same, even in developer2 system also at the same level. Now what I'm doing is, as a developer2, I'm also updating this code. Let me do ls and I'm updating only pom.xml file. So here change the snapshot version. This you can understand in my complete DevOps course if you have enrolled. If you enrolled only for the Git course, don't worry, it is just we are updating some content. And save this file and git status if I do. Here I have updated pom.xml and git add. I'm adding my changes to the staging area and git commit -m use updated pom.xml. Okay, so I have updated my code, and if I do git log over here, here also on top of my remote commit, I have done one more commit. Now in this case, even developer1 and developer2 both are updating the same local repository. Now whoever pushing their code first, they don't get any problem. Why? Because in remote repository, whatever commit is there, even these guys also having the same commit. On top of that one, we are updating. But whoever checking their code second time, they are going to get the problem. Why? Because if developer1 has pushed his code, then in the remote repository, commit ID should be this one. But whenever I'm pushing as a developer too, I'm still thinking that this is the commit ID. But whereas in remote repository, the commit ID became this one. Then we get a problem. Let's see that one. I'm pushing my changes at I am pushing my changes as a developer one. So git push origin master. Okay, I have updated my changes onto remote repository. If I go and refresh it over here, okay, one more commit which has done at 3 minutes ago. Now let me try to commit my changes as a developer too, and we'll see what happens. Git push origin master. In this case, what I'm thinking, still my remote repository is at this commit. On top of that one, I'm trying to update this commit. But whereas in the reality, it has one more commit. Now you can see, okay, while pushing, it is asking for credentials because I haven't set up any credentials over here. Revd. Okay, you can see here, failed to push some reference to so and so. What it is trying to say is updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same reference. So whatever reference I'm trying to push means on top of this one, I'm trying to push my changes. This is the reference I'm taking, but it is no more valid reference at this point. Why? Because there is one more reference point. On top of this reference point only, I can push it my changes. That is why you are getting this error. So to resolve this one, you need to pull the changes from the remote repository. Then again, you need to push it. Before doing this one, if I do git log, you can still see this. This is your commit, right? Now I'm going to do git pull. Okay, it is saying that merge branch master from so and so into your local system. Yes, I want to do this is take it as a one more extra commit in your local system. Now it has been updated app.java, and if I do git log, you can see here this is actually your local commit, and this is the remote commit which is pulled from the remote repository. But while pulling your remote repository, your code and remote repository code has to get merged. That is the reason you will get one more commit as extra, that is merge branch. Okay, now how many commits we are having in the remote repository? Initially 12 were there, then as a developer one, I have done one more commit, it became 13, but this time it should be 14, right? Instead of 14, it will become 15. Why? Because this merge branch commit also added in my local repository. And before this one, I could see another commit, that is what earlier commit E97E. Okay, anyway, if I do git push over here, this time it should be pushed into the remote repository. All right, I have successfully pushed my code onto remote repository, and if I just refresh it, this time it should be 15 commits. Okay, if I go to my commits over here, okay, merge branch is one more extra commit, and this is as a developer too, I have done this one. Before that, app.java, because he has pushed his code prior to my code. That is how you can push your code. But to overcome this problem, we are going to use branches. Most of the cases, developers, they don't commit their changes onto the branch which they are using. As a best practice, instead of doing your changes onto the branch which you pulled from the remote repository, you create your own branch and do the changes. That is how you can avoid these kind of conflicts. Anyway, you are going to understand about Git branches in the later point of time in this course. Thanks for watching and see you in the next lecture.